window to viewport mapping here. So we have two windows here, window and viewport, or two rectangular frames, and we're going to take points that are defined within one of them, within the window, and we're going to find the points that are proportionally the same within the viewport, so the corresponding points for them. The viewport being in pixel space, whereas the window is still in kind of continuous space. So we'll just start with looking here. We have this viewport is left, bottom, width, height. The viewport could also be set up as left, right, bottom, top, doesn't matter, but we have the width already calculated here, whereas the width of the window will be right minus left. The height of the window will be top minus bottom, but the height of the viewport is already here. So we can just start by finding the factors that we need. Let's start with the scaling factors and say, so we have 600, 200, and 800. So let's just start here and say A is basically the ratio between the width of the windows. So we have 800, I believe, was the width of the viewport, and 600 minus 200. 100 minus 200. So that's the width of the viewport divided by the width of the window. And then we have the scaling factor B, which is the scaling factor for the heights. So the height of the viewport divided by 400 minus 100. 400 minus 100. Okay, so here we have 800 by 400, which is 1/2. We have 600 divided by 300, which is also, no, sorry, it's not 1/2, it's 2, so the scaling factor is 2. Scaling factor here is 2. The fact that the scaling factors are the same mean that the window and the viewport have the same internal proportions. Them not being the same wouldn't change our calculations any, but them being the same means that we know that we're keeping proportion between the window and the viewport. So then we have the translation factors, C and D, where C is the left side of the viewport minus the scaled left side of the window. So we have basically viewport left minus A times window left. So viewport left is 0, window left is 200. So we have to scale from that 200 down to the 0 in order for the points to be in the correct places within the window. It's not enough to only scale, we also have to translate because the windows might not be positioned the same within their respective coordinate systems. So we have 200 there and we have 0. So C equals 0 minus 2 times 200, which equals minus 400. D equals 0 minus 2 times 100, isn't it? Yeah, the bottom. So we do the same on the height, meaning we use bottom like we used left before. Times 100, which equals minus 200. Okay, so we have our scaling factors and we have our translation factors, and then in the end we use these simply like this. We say Sx, which is the x point within the viewport, equals A times x plus C. So the scaled x coordinates within the window plus the translation. And then we have Sy equals B times y, y being the coordinate within the within the window, sy being the coordinate within the viewport, plus d. So it's as simple as this. And we can also set this up as a matrix and say the matrix A 0 C 0 B D 0 0 1, which in our case equals the matrix 2 0 minus 400 0 2 minus 200 0 0 1. And if we call this matrix here just the matrix T or the matrix M, T for transformation, you can say T times the point x, y, 1 equals the point sx, sy, 1, where sx and sy have these same formulas that we've looked at before. So let's just move this a bit up. Now we have all of these numbers here, and then we can calculate for the specific points down here. So we can say, let's see if we can do this. Right. Paste it again. Here. Here. And here. Alright. So we're going to calculate 4 points here. First point is 356,125. So this times 356,125,1 equals, so here we get 2 times 356 minus 400. Here we get 2 times 125 minus 200. Here we get 1. This equals, what is this? 712, 312. 312. This one here is 250, it's 50. 1. Next point, 200, 354. 200, 354. So here we get 2 times 200, which is 400, plus 0 times 354 minus 400, so we get 400 minus 400 gives us 0. Here we get 2 times 354, which is 708, minus 200, which is 508. 508 and 1. Okay, so this is the point, the pixel 0, 508. And the fact that this is 0 shouldn't be surprising to us, since its x coordinate is exactly the same as the left side of the window. So it's absolutely at the edge of the window, which means it'll be at the edge of the viewport as well, giving it point 0. Then we have the point 230, 400. That's another edge. 230, 400. Okay, so we have 2 times 230, which is 460 minus 400, so 60. Here we have 2 times 400, which is 600 minus 200, which is 400. We get 400 here. This one was on the edge, right? It's right on the top edge here. So that's 400 here, which should give us that's right. It should be on the edge as well, on the top, which is 600, and of course it is, because 2 times 400 is 800, minus 200 is 600. 600, and so we have the pixel 60, 600, and finally we have the point 564, 200, 564, 200, which gives us 2 times 564, which is 1128, minus 400 is 728, 28. 2 times 200 is 400, minus 200 is 200. One, giving us the pixel 728, 200. So this is pretty close to the edge of the window here, and this is pretty close to the edge of the viewport. So this is basically it. We get these numbers out, and we can use these same factors. If we're using the same window and viewport, we just calculate the factors once, the scale factor and the translation, and then we just use them to calculate all the points, either through a matrix multiplication or just through the formula we looked at earlier. You can just put into this formula here, Sx equals Ax plus C, Sy equals By plus D.